most complete thickness of metal here, despite the appearance of the troughing nearby. The water running through here, which is clearly what's caused the problem in this area. But the concrete itself is actually in very good order. This is one of the drains to take water from the edge of the road, drop it straight in the river. Unfortunately, it's rather near the edge of this flange, so it's been dropping water onto the flange of the longitudinal beam, which has caused quite extensive rusting down here. And also, I think probably a leak around the drain has caused moisture to be trapped up under here. And the rusting caused by water running down the side of the beam has actually caused it to rust right through at this point.
Cookham Bridge was built in 1867 and is listed Grade 2. It's carried traffic over the Thames near Maidenhead for more than 130 years, but was closed for just 4 months to allow major repairs. The structure is a series of cast iron trestles spanned by wrought iron beams and corrugated plates covered with reinforced concrete. The first task was to remove all the concrete to allow full inspection of the ironwork. An early decision was made to adopt strict conservation principles and retain as much of the original metal as possible. The thickness of every plate was checked and the wrought iron spans modelled by computer to enable the engineers to determine which wasted areas could be tolerated and which had to be patched. Corroded areas were cut back to sound metal and plates cut to fit each hole accurately. New steel plates were first tacked in place and then welded round by the MIG process, where the metal is melted locally by means of a continuous electric spark protected by a shield of argon gas at the torch. This produces a molten pool where the plates fuse together. The plates of the main span were just 6 millimetres thick, so a full depth weld from both sides was essential. Wrought iron is fibrous and contains small natural faults. The contraction of the hot weld often pulls the fibres apart, so it's important to test structural repairs for cracks. One very effective method is to spray on a white powder, attach a magnet and then apply magnetic ink. Cracks are ground out, re-welded and retested. The concrete deck is supported by corrugated troughs, again repaired by electric arc welding as necessary. Modern traffic puts a greater load on Cookham Bridge than it was originally designed to carry, so an unobtrusive method had to be devised to strengthen the roadway. Computer modelling proved that the most effective and least visible method was to make the troughing and roadway act as a single composite beam. This was achieved by fixing the ribs and deck plates together with a large number of bolts. The projecting bolts were cast into the reinforced concrete slab to act as shear studs. This tied the whole structure together as one very strong composite span. The plates, angles and tees of wrought iron structures were usually fixed together by rivets, always set red hot. As the rivet is hammered up, it spreads to fill its hole, locating the plates so that they cannot slide. When the rivet cools, it shrinks, pulling the plates together and producing a very strong and durable joint. To comply with conservation principles, riveting should never be replaced by welding on historic structures. Whether wrought iron or cast, functional or decorative, The aim in the repair of all historic ironwork is to retain as much of the original material as possible and stabilise its condition in accordance with sound conservation principles for the benefit of our successors.